Hello and welcome back to the channel. My name is Eddie Jennings from ejsllc.com. In this video, I'm going to continue my practice session series for the Red Hat Certified Specialist in Containers Exam EX188. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone who's watching, if you haven't subscribed, to click the subscribe button. And if you enjoy the video, make sure you click like. As a reminder, these are my practice sessions for the exam, which actually happens in just under a week. My goal with these videos is to go through the objectives, try to explain them, maybe do some examples of whatever it is the objective is asking of you, and do a little self-assessment at the end to see if I feel like I'm confident with whatever the objective is. If so, great. If not, then I have just under a week to try to brush up on a couple of things before taking the exam. These are not intended to be tutorials, nor are they intended to be training materials, but rather it's just me doing my my self-assessment. I do try to have the information accurate because hopefully I'm going to know what I need to know for the exam, but they aren't training materials. That being said, I am putting these, out on the internet, on YouTube for folks to consume, because perhaps some of the things that I do for my own practice, you might find helpful for coming up with ways for you to practice yourself if you're looking at this exam. One thing to keep in mind is these videos are being made March 2024. So if you find these years in the future, just bear in mind that this is what I was working on in 2024 to prepare for this particular exam. So the objective that we're going to look at is the last one within the running multi-container applications with Podman, and it is the working with configuration objective. And I've been critical of the objectives for this exam in a couple of the videos just because they seem pretty vague, and this is one of them. And when I was trying to think about the objective and also just think about this set of objectives, I've been running under an assumption that, this is probably talking about Podman Compose. Well, I was digging through some Red Hat documentation, and actually this is documentation. These are their, I think it's enable sysadmin articles that they do, which are generally some pretty good articles by Red Hat. And I was doing that because I remember when I was preparing for RHCSA, there were some objectives that it was not clear in the objectives, like this is the tool that Red Hat's wanting you to know about for your exam. And I remember that being the case. I think it was for VDO stuff, the virtual disk optimization. I was searching like the terms of the objective and came across some at the time RHEL 8 documentation that was named similarly, and those were the tools that the documentation was talking about. Well, this is kind of a similar thing, and I found the article on the enable sysadmin that talked about Quadlet, which I'm going to discuss with this. I haven't really practiced practiced using it that much, mainly because I've been doing my practice with Podman Compose, which was my initial thought of what these objectives were about. But one other thing that this working with configuration I'm going to practice in this session is making some systemd units. And I mean, I can't think of like what would be a specific thing that Red Hat wants you to practice with, quote, working with configuration. I mean, if you've been in the system administration space in any amount of time, that could configuration, well, that's everything. We're always having to configure something, either OS or application or some deal like that. So I'm going to take this session to work on some systemd stuff. And the reason being, none of these objectives mention systemd, but you have the line here in the objectives that's, as it even says here, with all Red Hat performance-based exams, configs must persist after reboot without intervention. Well, there's not a whole lot of stuff that rebooting is going to affect with this, such as, let's say, earlier in the exam, you have to write a container file for something, and you have to use some of these instructions like what it says. Well, if you are, and it wants the container file in some particular directory, well, you make your text file, you put in whatever instructions you need to build the container image the way the exam wants you to, and you save the file, and that's it. I mean, you reboot the system 1,000 times, the file's going to be there. And I think a lot of these things that is true. The one thing I could think of that might be a gotcha with that is, all right, so the exam wants you to have certain containers running. Well, if I were to, let me just go to Podman. We're going to make a quick little container here. I'm going to name it, --name web1. It'll run in the background, and we'll just use the Apache image. I'm not going to do any port publishing or the like, so go registry.access.redhat.com UBI8 HTTPD24. Unknown flag name, because I need to tell Podman what to actually run, which is Podman run. This will take a moment to pull down the image, then it'll make our container. All right, so we have our container, Podman PS. There's our container named Web1, and it is currently running. Well, this container itself, unless I've done the --rm option, which you're probably not going to be doing on the exam very much, because I imagine whatever containers they make you create, they're going to want to survive. This container is here. I can reboot this machine. I'll let it reboot real quick. Log back in. Podman PS, nothing is running. PS-A, that container is still there. So the container survived the reboot, however, it is not running. And so I would imagine if maybe one of your exam tasks is, have this container running, well, you have to have a way of making it run. The only quote native way that I can think of outside of if you're in some type of OpenShift environment that, is orchestrating all of your container stuff, which I'm fairly certain is outside the scope of this exam, is to run your container as a systemd service and enable the systemd service. I guess you could have a cron job that's, at reboot, Podman start the name of the container, or like Podman compose. I'm always using up and down with that. I'm pretty sure there's a command within Podman compose that's like just run the stuff because the containers are already there. You have like I said, a cron job run at boot time, but I think kind of the way Red Hat would want us to persist these kind of things is through systemd. So there's a couple of ways of handling this. Now, this is a rootless container. Let me go and start the container. Podman start. Web1, all right, and it's running. If I were to do, Podman top, I need to give it the container. Web1 H user. We see that this is not, this is a rootless container. It's, mapped to one of my sub UIDs, and the user that's running on the container is default. If I wanted to make a systemd unit file out of this, we can do a couple of things here. We are going to run Podman generate, and systemd is going to be the command, and then you would do your container, and it'll spit out a systemd file for you. Now, there's a couple of things you can do here. You can have it just make a file, and also I like doing the --name with this. Oh, this -f. There we go. And what that will do is give you a file that's actually named after your container. And if I were to cat that, it names the description becomes something a little bit more readable than just the container ID. And so the question becomes, where to put this file. And there have been a couple of things that I've noticed just with experimenting with this being a rootless container. What I have done to get this to work is you're basically doing systemd commands as your user. And so this should, famous last words in IT, should work. One place you can put this is within your home directory in config, and I'm fairly sure, and where I'm getting this directory from is actually going to come from the Quadlet thing that we'll look at in a couple of minutes, but we're going to make a directory, make dir config, I need to do -p for this. Config containers systemd. And what I'm going to do is copy container web service into that directory. Otherwise, there's another place that I think we can put this. Okay, so we're going to try systemctl daemon reload. And if I do this, it's going to prompt me for credentials. So we want to do this all in a rootless way. So systemctl daemon reload -- user. And so what we should see, if I were to do systemctl status, actually let me do something else real quick. Systemctl list unit, is it file or files? I never can remember that. User files. And we should, or I would hope, we would see, probably could have done type service. That would show us more. What do we call that? Config containers systemd. Called that container web. So it's not there. There's another place that this can be. I think it's .config systemd user. So let me make that directory real quick. Is it systemd system user? When in doubt, man systemd. So I know you can do etc systemd system and such. Where is this file path? Probably something I do need to try to commit to memory. Yeah, systemd system. I know you can do it in etc. That's when I put my stuff in for work. User unit directories, systemd unit man5 for that. There we go. So it would be config systemd user. Yeah, this was it. This is what I was looking for. All right, so we're going to dump it in there and see if it's picked up. So I think the other thing is for the kubelet thing that we'll talk about. All right, so still should have this here. So let's make our directory. -p. -p will make all of the parent directories as needed. Systemd user. All right, so now let's copy container web service into config systemd user. I could of course just moved it, but I'd rather copy. And we'll do our systemctl daemon reload -- user. And let's do systemctl list. I'm just curious if I just do list unit type service. See if it shows up there. Not serifisa, but service. I got to put a space between that and user. We'll do list unit files. Drop the all, and there it is. Container web 1.service. And we see that it is disabled. So I'm going to stop this container because that is one gotcha. If you start a container with systemd and you then, well, I think if you have a container running and then try to start your systemd service of the container, systemd is going to flip out and say, nope, can't do that. So we have our systemd service. So systemctl status container web 1.service. And you always have to do user with this because by default it's going to try to look at it system-wide, not just in your user scope. And we see it's inactive, we see it's dead. So let's see if we can start this service. ctl start container web. Let me do -- user. Maybe I can get some tab completion with that. Yeah, I can. Excellent. All right, so looks like no errors. Let's take a look at the status. According to this, it's running. Kind of nice that we see the process IDs that are related with this. And if I were to do Podman PS, we see that it is running. Now we can stop this just like any other systemd service. And we'll see if we look at the status, that's obviously not running, but it is a loaded unit. And Podman PS, obviously it's not running, PS-A, it still exists. We can enable the service, which this is what's going to have it run on reboot. So systemctl enable, and of course you can do like start dash or enable then dash dash now to start it, but we'll just enable the service. User container web1.service, and of course it makes the symlink there, and it creates default. Okay, cool. So now let's reboot the machine again, and we'll see the status of our container. So while we wait for this to reboot, I guess this is the work with config or work with configuration that the objective is talking about, right? I'm configuring unit files for systemd. All right, Podman PS, and there is our container. Came up 9 seconds ago. Now, of course, the systemd service will show this as running. I'm curious to see. Let's stop the container. I want to see what systemd looks like with this. So systemctl status user container web service. All right, it shows as inactive, as it should. Let's see if we can start it. Should be able to start it. Yep. And if I were to look at the status, we'll see that it's up. What I'm going to do this time is stop the service. There was some scenario that I helped get things confused here. So I'm trying to think. So stopping the container stopped the service. Oh yeah. If I stop the service, that stops the container. But I start the container, I don't think the service will start, which it kind of makes sense because Podman doesn't really care about systemd, or there's probably people I'm sure that would argue with that. Web1, yep, and let's check the status of our service, and it should still show that as down. Yes, and then if you try to start the service, it's going to complain, and that kind of makes sense because hey, this is already running. So maybe a little troubleshooting thing for you. If you can't start your service, see if that container is already running. One other thing with the systemd that I want to show you is having systemd make a new container each time this is run. Now, and I think that's what this will do. So let us we're going to remove. Easier if I just go into this directory. All right, so we're going to remove container web. It's going to be a broken link, unlink. Okay. And Podman rm-a. Okay, so now what we're going to do, we're going to make another web server container. Podman, we'll call it web2 this time, run -d, name web2. Actually, we'll go ahead and do the port publishing of this. And of course, the container doesn't necessarily have to be running to do this stuff with systemd, but we'll do Podman generate Kubernetes things with this too, which that's beyond my knowledge right now. Do -- help, and you can do this for pods as well as individual containers, which I think that would be a way of multi-container application. You put your stuff into a pod and then make your systemd unit files, but the one you enable is the pod, not the other units. But we can, I guess I'll take the time to demonstrate that too. But this --new is going to create a new pod and container instead of starting an existing one. So let's do this. We're going to --new, I guess --files, plural, name, do web2. All right, and let's take a look at this service. So restart on failure. It's running Podman run. I'm not seeing anything I'll bet. Yeah. Okay, this makes sense. Notice how it's doing --rm, which is our, when you stop the container, it's blown away. That's what that's doing. Let's compare that to, because we should have our old container web 1 con cat container web 1. And there it is just starting the container versus doing the RM thing. So what we can do, if we want to add this to our systemd service, we can copy container web 2 to config systemd user, and we'll go ahead and enable it. Systemctl enable user. We're going to, we have to do daemon reload first. All right, now systemctl enable --user container web service 2 -- now, so that'll start it. All right, so let's look at Podman PS. All right, and we have our container there. Notice it says created 6 seconds ago and 11 seconds ago. So let's stop the service. Systemctl stop user container web 2.service. If I can spell systemctl right. Podman PS, obviously it wouldn't be there, and there should not be a container there because we use, when we created the systemd unit file, we had the --new, and so every time that you run systemd or run the service, it's going to make a new container. There's our container, and it was created 2 seconds ago. Let's see. I think I talked about wanting to demonstrate this with a pod, so let's do that. Systemctl stop container web. User container web 2.service. I'm curious. List unit files user type service grep container. Not typer. Just type. Okay. I noticed tab complete stopped at web. It didn't do the 2, so I was wondering if that web 1 service was still around, but it does not appear to be. Or let me add a all, see if that makes a difference. No, it doesn't. So we'll go into here, blow this away because I want it to be clean. Unlink default. So let's make a pod. Let's call it test pod, test post. Nope, we want test pod. And we'll rm test post. All right, so we're going to do our little, I'll make a HTTPD container and a MySQL one and attach it to the pod. So Podman, we'll just do create this time. Name will be web1 pod. Yeah, we have to I think we have to set the port to publish that with the pod. So let's do podman pod rm test pod 1. Let's create one. Take a look at -- help real quick about the, so publish strings. Looks like that'll be 8080 8080. All right, we can do that. So podman create pod, do -p 8080 to 8080 test pod. Oh, I see what it's trying to do. Podman pod create. Okay, and if I were to do podman inspect or pod inspect, see what we get out of this. Okay, cool. Because remember, the pod is going to have that, automatically have that intra or infra container. That is the, maybe liaison is a good way of putting that between what's in the pod and the kernel namespace that the rest of the system's dealing with. All right, so now let's Podman create. Name web1, pod will be test pod, and we know our image. So that'll be, actually it'll be, should already be downloaded. Yep. Okay, so I'm happy about that. We'll do our Podman search for the MySQL one because I still haven't memorized that. There it is. Call this db1. And we're going to make an environment file. Just because I don't want to type all that stuff out again. Put the good old MySQL user equals foo. MySQL password equals foo. MySQL database equals foo. All right, so now env file will be env.text. We have test pod, and let me paste the name of the image. All right, we have our little pod of containers. So now what we can do, let's do Podman generate systemd. We're going to, not sure if new will work with this. I guess we'll try that in a bit. But we'll do files, and then we want to use the actual name and test pod. And notice this is going to make 3 systemd unit files. One for the test pod service, and then database, and then web. Let's take a look at the pod one. And notice how we have some once, and also this needs to be running before those 2 services run. One thing that would be useful for this, like let's say that you have to, or maybe there's something on the exam that makes you write this manually. You could just spin up a container, dump out a systemd file, and you now have a reference to what's going on, which I think is kind of a nifty way to create your own documentation mid-exam if you need it. So we will cat container web1.service. I wonder if that overwrote what was there. I imagine probably. Yeah, that would make sense. And actually we can do this. Yeah, so it overwrote it. 1847 for the time there. And our container db1 is here, and notice there is things that attach it to the test pod. So what you actually are, the service that you are running and the service that you enable when you're doing a pod is the pod service, not the individual containers. I'm not even sure if the individual containers will run. I guess we can try that out, but I'm going to get rid of container web 2. And let us copy to config systemd user. All right, so all of those should be in there. We have Podman ps-a, all of those are there. They're created, so they are obviously not running. That's neat. So it will do the port for a database as well. Maybe there's something that I can specify with creating a pod that would say only for a certain container. I'm not sure about that. I would have to do some research with that. All right, so let's do our systemctl daemon reload -- user for this. And let us do systemctl list unit files type service. Oh, need to do this for user. All right, so there's our container service and the pod. There we go, testpod.service. So let's do systemctl enable user. Let's see what happens. We have all 3 of our containers running. It's going to be kind of interesting. Let's see what happens when I actually browse to localhost 8080. Oh, we get that. Because the reason why I think it's curious is, this looks like, if I do, Podman port -a, Like all of these containers are publishing for that. You know, the little infra container. So yeah, I'm genuinely curious now. So let's do Podman inspect, or pod inspect test pod. Pipe that to good old JQ. Let's see what we have here. I know this is obviously outside the scope of what I was wanting to do, but you can learn from, yeah. But yeah, clearly it sent the traffic over to the web server, because I know the database server is not listening on 8080. And let's look at our Podman, not Podman, systemctl list units again, our unit files. And so these are still disabled, which kind of makes sense, because really what we're wanting to run is the pod. And let's reboot and see if this survives the reboot. I'm fairly certain that it will. All right, so we'll log in. Podman PS, and our little pod is up and running thanks to systemd. So all this is done within the scope of user, because these are rootless containers. The thing is, if I were to dump these into just etc systemd system, let's actually try that. So we'll do, actually, there was another thing I wanted to try. This is actually turning into far more stuff than I had expected. I was actually kind of worried about this video. Some of you that are familiar with my other practice session series are probably laughing. It's like, Eddie, you always talk too much. So, all right, what I wanted to see what would happen would be, I'm going to get rid of these service files. Was if I did podman generate systemd new for test pod, and just want to see what this does. So it does podman pod create. Okay, so yeah, it blows away the entire pod. And okay, I am curious if it does the same on the individual containers. I guess it does, because I know if you get rid of the pod, it'll get rid of the containers as well. All right, so that answers that. You can do the -- new for it. So the thing I was wanting to test is putting this at the system level systemd. So let's do podman stop, not podman stop, systemctl stop user pod test pod.service. All right, and we'll go into here, get rid of all that stuff. Systemctl daemon reload user. Now, since these were rootless containers that was made by this, I'm curious if this will work for dumping it into actual etc systemd. So let us, let's do podman pod rm test pod, because we set these services to do it as new. And what we want to do is sudo cp *service to etc systemd system. All right, so doing this as root now. And all right, so we have the little container service. We should have our pod test pod.service. I'm just curious to see if we can even start it. So systemctl start. Okay, so it's going to want root credentials. Oh, I was actually expecting an error. Oh, not start. I want status and spell systemctl correctly. Huh, so it is actually running. So obviously we're not going to see that. All right, so in the root namespace, or I guess root namespace, but from root's perspective, oh, so I guess it delays it just a bit. Oh, I know why it's taking so long. It's having to download the image for the containers, because root's instance of Podman does not have that that image yet. though I would expect it to be done by now. And I wonder if that failed because of environment variables. Huh. So let's become root for a moment. All right, so it downloaded the images. It actually did not even create the container. So let's just see what happens if we try to start that service. I have a feeling on the exam, if you're doing stuff as just the user, it's not going to gripe and complain, or it's not going to expect you to put this stuff into like the overall system's systemd thing. Just doing it as the user will be fine, but that's curious. Let's take a look at the service. Ah, yep, that's why. It was the environments, because in, I guess, root's home directory, there is no env file, env.txt. So let us copy that to root's home directory, and we're going to restart the pod. And let's see what happens. All right, so that's running. Looks like we still lost the, we'll know in just a second. Yeah, so that's what it was. It's the environment file. So now I'm curious, like, where does this need to live? Obviously root. I'm trying to think what directory. I probably should know this. Systemctl cat container db1.service. Trying to see if it's given me, see. Stop, run. What directory is it running out of? Is it just root? All right, so let's copy env. Let's see if it'll start now. I doubt it, but we'll see. Container. I guess that was what it was looking for. So let's do Podman. No, let's do systemctl restart the test pod. All right, Podman ps. And we have 3 containers running. Huh, nifty. So that's what it was doing. It's looking just in the, I probably should know that, but it's looking just in the root directory for the env.txt. Well, there you go. Kind of added bonus of learning for everybody, myself included. So the last thing is this idea of kubelet, or is that one? No, quadlet. And let me give a little bit of history of how I found this. So back when I did R8CSA, I had to search for some stuff in the documentation to figure out what the exam is going to use. Or not that, it was, I had to figure out what tool the exam wanted me to know to work with something. And the example that I remember is VDO. I think it was, I can't remember what the objective is now, but ultimately I searched for the objective. I found the link to Red Hat Enterprise Linux 8, just general system documentation, and led me to that. So because I was trying to figure out what this configuration was. So I literally, and you're going to watch the Google search right here. I Googled Red Hat multi container configuration. And what came up was one of these enable sysadmin articles that talked about quadlet. And so I'm kind of freaking out at this point, because, you know, my exams, today is Saturday, March 9th. My exam's Friday, the 17th. So, you know, just under a week away. And I have been working with the Podman Compose stuff. As if you've watched any of the other practice session videos, you'll know that. I've obviously practiced stuff with systemd, but I'm like, so where, you know, how would you, let's say you didn't, the only thing that you were using for training is just the objectives itself. You're not using any type of course or anything else. How would you know that this is referring to it? I don't think and honestly is the only reason why I suspect that Podman Compose is being used for this is because some of the training stuff that I've done, when they got to this section, the tool they were using was Podman Compose. Plus, it's a good thing to know anyway. So I come across this, and I'm thinking, you know, if you didn't, how would you know otherwise from the objectives? And what this is doing, this actually is a project that looks like it's defunct if you go to its GitHub. This was archived in December of 2022. But this little quadlet thing it's like another way of making your systemd files. And what it's expecting, and you can actually get a little bit of information about this by, even though there is no package for Quadlet, if you let me go back to my user account. Doing man Quadlet will bring you to the Podman systemd unit page, and this is talking about making units with Quadlet. And what this is doing is you dump these files into one of the paths here. That's why I tried the etc container systemd users earlier when I was doing the actual systemd files. You can make a file that's .container that is kind of like a Podman compose file. You can go through the documentation here, and it'll give you some examples. Let me go to the end of it. It'll give you some examples. And what you would do is, in one of those directories that's at the top of the man page, I'm not going to demonstrate this because I literally found out about it tonight when I was doing some just trying to figure out exactly what that objective was, because something didn't sit right about just it being Podman Compose. But of course I'll find out next Friday, and of course I can't share it if I do find out because of NDA. But anyway, in that directory you will make a little file for your container, and it will exec is basically what you're going to do, is analogous to entry point. If you want it to create a volume and network and such, and then when you run daemon reload in the background, this is going to happen. Let me go to user libexec podman, and we see Quadlet. And if I just run Quadlet, oh yeah, oh, it's not in the path. So like which Quadlet is not going to come up with anything. And do dry run, it's going to complain. Oh, let me spell dry run correctly. It's going to complain that there were no files parsed from any of these things. If I do -user to be in the user context, nothing was parsed there. And so what it's going to do is parse those files that are mentioned in the man page and generate a systemd unit file that, if you're doing it in home, it's actually going to deposit it and run basically your user directory within the /run file system. And that is, it's like behind the scenes will make your systemd unit files for you. And so all I have to do is start your service or start or enable your service, and the stuff just magically works. I could potentially see the value in that. I'm not going to just try to cram this into my head in the last week. I think that's unwise. I don't want to neglect doing some minor reviews over my other stuff, but I was pretty concerned about this, and then I realized what it did, and you can achieve the same thing by you just make your containers and then spit out the systemd unit files. But I did want to mention that because maybe, I know RHCSA objectives changed after I took the exam. Maybe these objectives will change, and it will specify, utilizing Quadlet, do this thing. But I get a little annoyed with Red Hat with their objectives sometimes, because I understand, they don't want to give you a thing of, well, you just memorize these things and you'll pass the exam, because it's performance based and they obviously want you to have to think. But anyway, just the grumblings of a sysadmin trying to learn. I think as far as whatever working with configuration means, I have a decent understanding of turning this stuff into systemd services, so that way containers are going to run on startup, which I think would satisfy this piece. I guess unless the objective explicitly says have this container running at startup, you're probably not going to have to do this. But if it does, I think the way that Red Hat is probably wanting us to do is to use systemd unit files. So hopefully you enjoyed this video or got something from it, or got some ideas of how you can practice this on your own. If you did, make sure you click like. As always, I want to thank returning subscribers for watching another video, and if you're watching and you haven't subscribed, to click the subscribe button and ring the bell so you know when I put up new content. I don't do it all the time, but you'll at least be notified when I do. As always, thank you for taking the time to watch, and I will see you the next time.